exercise 2.2 and the first question. So this is question 221. Find the zeros of the quadratic polynomials and verify the relationship between the zeros and the coefficients. Now, in this question, we have been given a couple of expressions, quadratic polynomials, and we are supposed to find out their zeros. Zeros means when the graph actually cuts or crosses the x-axis, and in order to get that one, we have to equate it to 0. We can solve this quadratic by quadratic equation, or we can factorize that. Either method is fine. I'm going to use the factorization method. The last term is -8, so I have to factor -8 in such a way that the middle term, their combination sum total, will be -2. So my factors will be -4 and +2. So let me split the middle term in such a way, -4x plus 2x. Remember, you have to always factorize the last term such that the addition of the two split factors is equivalent of the middle term. -8 can be factorized as -4 and +2. -4 plus +2 will give you -2. And from the first two terms, I will take x common, so x minus 4 remains. From the next two terms, I will take 2 common, so x minus 4 remains. X minus 4 is a common factor. X plus 2 is leftover. We will put that in another bracket. So the zeros of this quadratic expression is 4 when we equate this factor equal to 0, and -2 when we equate this factor equal to 0. So these are called the zeros. If you plot a graph of this equation using any scientific calculator, or let's say, or manually, so you will find that that graph will cross the x-axis at 4 and -2. Okay, this is just a fraction of the solution. We have to verify the relationship between coefficient. Now, in quadratic expression, these are the two roots of the equation. We know that sum of the roots, well, we physically add them, 4 plus -2, that's equal to 2, and product of roots is 4 times -2 is -8. Now, we are supposed to cross-check, verify using the standard formula, and if it works out to be correct, then our solution is okay. Now, we know that this is a quadratic expression. So in the format ax square plus bx plus c, so the coefficient of x square is 1, that's a. The coefficient of x is -2, that's b. And coefficient of, the constant coefficient is -8, that's c. We know that the sum of roots is given by -b upon a. -b is minus of -2, that's +2, divided by a is 1, 2. And product of roots is always given by c upon a. So c here is -8 divided by a, which is 1, so -8. What exactly is required from the solution? We have calculated sum and product of roots by manually factorizing, manually solving that, and actually evaluating the zeros, and then manually adding and multiplying them. That's one way. And the second way is we have used standard formula for sum of the roots, -b by a. Standard formula for product of the roots, that's c upon a. So if these numbers are matching, let's see. So here sum of root came out to be 2, and which is matching with this one. And product of roots came out to be -8, which is also matching with -8. Now let's go to the second question. We'll repeat this process. We'll equate it to 0. We'll try to factorize this one. And the factors will come out to be 2s minus 1 and 2s minus 1. Actually, this is the square of 2s minus 1. If you recognize that and you can directly write that, that will be even better. But let's assume that we have got, I purposely avoided that method because I wanted to show that these are the two equal roots, and those are half and half. So if we manually add them, the sum of the roots will be half plus half, and that's equal to 1. And the product of roots is half times half, which is 1/4. This is one way. Now we will use the standard formula using the coefficients, cross-check and verify. A, B, C values are taken from whatever are the coefficients of the square term, linear term, and the constant sum. So that will be 4, -4, and +1. 4, negative 4, and plus 1. So sum of roots is minus b by a, which is minus 4 by 4 is 1. And product of roots is c over a, which is 1/4. And let's cross check whether they match. Sum of the roots matching with sum of the roots. And product of the roots is also matching with the product of roots. So this solution is correct. Let's see the third sub question. 6x squared minus 3 minus 7x. Nothing spectacularly different. The only thing is they are trying to confuse you by giving the constant term first. So let's fix that right in the beginning. Remember, quadratic term, which is the square term, has to be first. Constant linear term has to be followed by that, and constant term always last. It should be in the format ax squared plus bx plus c. So this was not in the format. This negative 3 actually has to be after negative 7x. So same process. Now here, since we have some coefficient in the beginning, now 6 times negative 3. So we have to do 6 times negative 3. So that's negative 18. And negative 18 has to be split in such a way that the middle term comes out to be negative 7. So the two factors will be minus 9 and plus 2. Their multiplication is negative 18 and their addition is negative 7. So from first two terms, I will take 3x common, and that will leave 2x minus 3 from these first two terms. And here there is nothing common to be taken. So I will just take 1 as a common, and that will leave 2x minus 3. Remember, the whole idea of splitting the middle term in a specific way so that eventually you will get at least one bracket common, and that common bracket has to be written only once, and whatever is left over has to be substituted and put into the second bracket. So now we have got two factors. Let's assume the first factor to be 0. That will be minus 3 will go on the opposite side. So 2x equal to 3 and x will become 3 by 2. If you assume second factor to be 0, 3x equal to negative 1 and x equal to negative 1 by 3. So these are the two zeros. We will manually add them to get the sum of roots, and we'll get product of roots. Now let's cross check and verify using the coefficients. Here a is 6, b is negative 7, c is negative 3. So let's assume the same procedure. Sum of the roots will be negative b by a, that's negative of minus 7 divided by 6, and product of roots will be c upon a, c is negative divided by 6, that's minus 1 by 2. So let's cross check here, sum of roots matching with sum of roots, product of roots also matching product of roots. Let's go to the fourth sub question. Here you will find that there are only two terms. This is still a quadratic. Only thing is constant term is missing. So it should not bother us that much. We'll just write this as it is equated to 0. We can take, in fact, this is actually simpler because you can take 4u common from both the terms, and that leaves u plus 2. You can get rid of 4 because on the right hand side there is 0. Even if you divide the entire expression by 4, nothing bad will happen. So u times u plus 2 equal to 0. That means either u will be, this should be u actually, u should be 0, u should be negative 2. So the sum of roots will be 0 plus negative 2 is equal to negative 2, and product of roots will be 0 times negative 2 is 0. Now here you have to be a little bit careful. A is 4, b is 8, and there is no c because there is no constant term. So I will write c equal to 0. So sum of roots using the standard formula, negative b over a minus 8 upon 4, that's negative 2. Product of roots is c over a, 0 upon 4, that's equal to 0. Matching with sum of roots, product of roots should be matching with product of roots. Our solution is correct. Let's go to the fifth one, t square minus 15. Again, this has only two terms. This does not have the linear term. It has quadratic term, constant term, but the middle term is absent. It should not bother us. It's still quadratic polynomial. Now, this can be written in the form a square minus b square. So the factors are a plus b and a minus b. So one factor will be t plus root of 15, and another factor will be t minus root of 15. Why? Because we know that a square minus b square can be split as a plus b, a minus b. Equating each factor, the answers will be positive 15 from this factor and negative 15 from the other factor. If you make the sum of roots. Well, these two factors are equal and opposite, they will cancel each other. The sum will come out to be 0. And the product will be coming out to be root 15 times root 15 is 15, but there is a negative sign associated with it. So the product will be negative 15. Now let's cross-check and verify that using the coefficient formula. Here A is 1, B is, well, nothing, 0, and C is the constant term, negative 15. Sum of roots will be minus B over A, 0 over 1, that's 0, and product of root is C over A, that will be negative 15 divided by 1, so minus 15. So again, let's cross-check whether these are correct. Yes, sum matching with sum, product matching with product. And there is one more question, 3x square minus x minus 4. You can use quadratic expression minus b plus or minus square root of b square minus 4ac upon 2a. In some cases, it will be advisable to do that. If you cannot find out the factors in the equation in the exam, if you are having difficulty with factorization, I recommend you straight away go to the quadratic expression form, right? So let me factorize this one. 3 times minus 4 is minus 12. Minus 12 can be factorized as negative 4, positive 3. So I will split that, the middle minus x, as minus 4x plus 3. I will take x common from the first two terms. I will take, well, there is nothing common, so I will take only 1. 3x minus 4 is repeated, written once, and the leftover is also written once. So that will give us these two factors. The sum of the roots will be 1/3 and product of the roots will be negative 4/3. Let's cross check and verify A, B, C value. A is 3, B is negative 1, C is negative 4. Sum of roots using the standard formula, you get these values. Now let's cross check whether these two are correct, and product is also correct. So our solution is correct.